Geometry, Lesson 10.2, Areas of Trapezoids, Rhombuses, and Kites. Recall, the bases of a trapezoid are the two parallel sides. They do not have to be on the top and the bottom, but they must be parallel. The height of a trapezoid is the perpendicular distance between the two bases. The area of a trapezoid is 1/2 height times b sub 1 plus b sub 2. And I like to think of this one as 1/2 b sub 1 plus b sub 2 times the height. Because then, in my mind, this number is averaging those bases together. So then that number would stand for the average base times the height, and that makes more sense to me. But you can use whichever. Find the area of the trapezoid pictured below. So it looks like our bases are the 3 and the 8. So I get 1/2, 8 plus 3, and then our height is 5. So we get 1/2, 11 times 5 for 27.5 square meters. Here's another trapezoid. What is the area of trapezoid PQRS? So area, 1/2 B1 plus B2 times the height. It looks like we have our two bases, so I'm going to plug those in. We're just trying to figure out what the height is. So I see a 60 degrees marked in there, so I'm thinking we're going to have to use our trig. So I'm going to draw in the height that we're trying to find right here, and I'm going to call it x. So it looks like I could use special right triangles if I want. So if that one is 60, this angle is 30. So opposite of 30 is 1, opposite of 60 is square root of 3, opposite of 90 is double. So it looks like I need to figure out what this side is. Well, if this is 5, and this whole side is 7, then this has to be 2. So I'm going to label that 2. So our ratio is 1 to square root of 3, so short leg to long leg equals short leg to long leg. So that longer leg is 2 roots of 3, and that's what our height is. So 1/2 of 12 is 6. 6 times 2 is 12. So we get 12 roots of 3. If we had to round this, that would be approximately 20.8. Label would be square meters. You also could have used SOHCAHTOA, where you have opposite and adjacent, so you would have had the tangent of 60 equals opposite x over adjacent 2. So on your calculators, if you do 2 times the tangent of 60, you would have gotten an approximation of 2 roots of 3. That means it would have been a decimal. Here's the formula for the area of a rhombus or a kite. We get 1/2 diagonal 1 times diagonal 2. So D stands for diagonal. So that goes from vertex to vertex. So in this kite, our formula is 1/2 diagonal 1 times diagonal 2. So one of the diagonals is 7, 5 plus 2, and the other diagonal is 6. So I'm looking at an area of 21 square meters. So let me explain where this formula is coming from. If I take this part of my kite and I rotate it, it could fit right on here. And notice that this part of that kite is the exact same thing as the top. So it's like I took this green piece and I turned it and put it up here. So I'll do the same thing over here. I'm going to take this green piece, turn it, and replace it up here. So then my shape looks like this, and this part of the picture would be gone. So now it's like I have a parallelogram. So if we look at that, this longer diagonal was 7, and this shorter height is 3, because it's right here. So that was half of this other one. And that also gives us 21. The other thing that we could think of is we have a triangle on top and a triangle on bottom. So 1/2 base times height for the top triangle, 1/2 base times height for the bottom triangle. If I factor off that half, I get half base times height times 1 plus 1. So then what I get is 1 plus 1 is really 2. Half of 2 is really 1. So then again, I get base times height. And this is one of those algebraic proofs that you'll do more in your pre-calc classes. So the formula for a kite is 1/2 diagonal 1 times diagonal 2. So here is a trapezoid and here is a kite. Please pause the video and let the students work. In the first example, we have one base of 8, the other base is missing, and our height is 12. So I know that this side is 8, so I need to figure out what this side is. And I'm going to do that using Pythagorean theorem. So I have 14 squared equals 12 squared plus x squared. So 196 minus 154, and then we take the square root, and we get about 7.2. So those two numbers added together is going to give us a 15.2. Plug and chug that on the calculator, and we're getting 139.2 square yards. In the second example, we're doing 1/2 diagonal 1 times diagonal 2. So 8 plus 8 is 16. We're still looking for diagonal 2. But I'm looking at this picture and I'm noticing that this one is 8. So that second diagonal is really 22. So let's double check the first diagonal. The first diagonal has markings here and here, so I agree that our 16 is correct. So 8 times 22 is 176 square inches. These next examples get a little more involved. When I see an angle measure, I'm thinking I might have to use some trig. So first name the shape. This is a trapezoid. So I have 1/2 base 1 plus base 2 times the height. So one of my bases is the green, and the other base is this green. So I know one of them is 9. And then I don't know what the height is, so that height is this dotted line. So I'm going to use this special right triangle. Opposite of 30 is 1, opposite of 60 is square root of 3, opposite of 90 is double. So I'm going to find the height first. Our ratio is 2 to 1. hypotenuse to short leg has to be equal to hypotenuse to height. So h is going to be 6. So now I can go from the 6 to the longer leg. So 6 to the longer leg has to be equivalent to 1 root of 3. So that longer leg is 6 roots of 3. So this long green base is 9 plus 6 roots of 3. So I'm going to write it like that, just so we can simplify some things. So half of 6 is 3. And I get 18 plus 6 roots of 3. So on my calculator, I'm going to get 18 plus 6 roots of 3 on there first. And then I'm going to multiply that by 3. And I get 76.2 square inches. In the second example, this looks like a rhombus. All sides are equal. So formula for rhombus is 1/2 diagonal 1 times diagonal 2. In a rhombus, if you remember correctly, diagonals bisect. So if this is 15, this is 15. If this is 12, this is 12. Maybe we should write that down. Rhombus. Diagonals bisect. So the 15 turns into a 30, and the 12 turns into a 24. So we get 360 square meters. I'm going to stop the video here. We will finish the notes in class tomorrow.